back everyone this week. So this will be our final experiment for Chem 125. As always, my name is Emma. Alright, so for today's experiment, we'll be making instant ice, meaning like we can make ice like that from liquid water. Basically, it's water bending, but in real life, not in movies, in real life, and we're going to do it today. Okay, so like, how are we going to do this? What are you talking about, Emma? I promise it totally makes sense, and it's super cool. All right, so we all know that water freezes at 32 degrees Fahrenheit, or in the dead of winter, or 0 degrees Celsius. Or does it really? All right, so when water freezes, it actually needs a nucleus, meaning something in the center, in order for the solid crystals, aka ice, to form. Water is typically full of particles and impurities. So when something's raining or snowing outside, there's impurities in the air. Some of them can be lead. It could just be some gas, a whole bunch of different things. So, as I mentioned, the water is typically full of particles and impurities, which have no problem kicking off the crystallization process. However, purified water, such as that in a Brita filter, bottled water, DI water, water in the jugs that you get from the store, the purified water, by definition, doesn't really have those impurities. So with nothing in this purified water, the molecules to latch onto, the purified water can be super cooled as far as negative 40 degrees Fahrenheit or negative 40 Celsius. All right, so what are we going to do for today's experiment? All we're going to need is basically just some bottles like this, or some bottles of water if you have, some ice cubes right here, a glass, a freezer, which is in my kitchen, but you have to trust me on that, and some purified water. How I mentioned, I'm going to be using an empty bottle. All right, so as usual, safety is paramount. That means nitrile gloves, no latex, because latex can absorb some things. We have a long covering for our top. I don't have a lab coat, but I do have a fleece, that doesn't mind getting dirty. And as always, our safety goggles. We have some long pants and closed-toe shoes so nothing gets hurt. All right, so what we're going to do is take your bottles of water. If you just have some, bottles of water, you're just going to be popping them into the freezer. But I just took some spare bottles that I had from the recycling, cleaned them out, fill this with water, rinse them thoroughly, and then fill them up with water from my Brita filter. If you don't have a Brita filter, you have another purifying system, whatever, it's all the same. So just do that. A little bit of a mess. And you want to do this about maybe 3-4 times just to have a couple of extra on hand. So you never want to fill up the water bottle up to the tippy top because, as we know, when we make ice, it actually expands. So we want to just leave a little bit of room. So you want to do that. Fill up your water bottles, 3-4 times. I did this beforehand just to save some time. All right. So when we do fill up our water bottle with water or using bottles of water, we want to try to make sure that the water is actually free of impurities. As I mentioned before, impurities can be things outside that come from the drinking water from our tap, the cleaning chemicals in it, those count as impurities. So by making sure it's free of impurities, this helps to ensure that our experiment today is successful. So why is this so important that we use bottled water or water that has been purified, such as an Brita filter or your home purification system? Well, it's because the bottled water, purified water that you're using, doesn't really have any particles to start the nucleation process. So the water can cool in less than 0 degrees Fahrenheit before the ice crystals form. So that's the reason why we kind of want to use purified water, not just water straight from the tap. So we're going to take our bottles of water, or your pre-purchased bottles of water, and it's going to pop them in your freezer, preferably on the side, just because water tends to freeze better that way. And we're going to pop them in there for about maybe 2 to 2.5 hours. We're going to want to make sure that the bottles of water are removed from the freezer before they freeze. Now, you'll know when the bottles of water that you're freezing are ready when ice crystals form just a little bit when you jostle around the bottle. So you're going to want to do that. and then we can start the experiments. Now that about 2.5 hours have passed, we're going to remove the bottles of water from the freezer. So now for today, we are going to be doing two different things. We are going to be making an ice tower using ice cubes in the water, and we're going to snap freeze an entire bottle of water just with one snap. Sorry about that. That's just my little cat saying hello. Say hi. Hello. Sorry about that. She's not feeling too good. She just wants a little bit of attention since she's feeling under the weather. All right, so here's one of our bottles. You can see there's no ice, liquid water. You can see the top of it. Now, what we are going to be doing is taking this and just doing a quick little tap. Now it's really important for when you do this to make sure they're directly out of the freezer and not be waiting a couple of minutes. Grab the fresh one, it's liquid, and I'm just going to smack it. Hard tap against the table. That's right down here. And we can see the ice turn to ice. Okay, so why did this happen really? Well, it's easier for the water molecules to turn on the ice on top of an already formed crystal. And we can see the ice crystals as they were being formed build on top of one another and eventually freeze the entire bottle of water as it's frozen. My hand's really warm right now. It's pretty warm in here. It's about 74 degrees, so it's already starting to melt a little bit. All right, so the process of starting these ice crystal formation is called nucleation. Nucleation is a process by which one small action starts a chain reaction. So this starts from an impurity or a scratch or a piece of dust on the container that's holding the water. In this case, that impurity would be the water bottle, meaning the outside from the plastic. So once the ice crystal attaches to the imperfection, in this case, the plastic water bottle, and then the other ice crystals grow on top, as we saw it just grow on top. So basically, when you freeze the purified water and suspend it in an almost ice state until something triggers that nucleation process. When you hit the ice bottle, when we were smacking it up against the table, like that, the water molecules were bouncing off of one another really rapidly. And in doing so, they essentially formed they essentially instantly formed ice crystals. So when ice freezes, the water forms small crystals that were gradually spreading into a lattice structure. Now, if we catch the cold water before the crystals have time to form, we can still make sure that our water can pour out easily and that the water will freeze as we smack it up against it. So we saw that happen. You know, it was still liquid, and smacked up against it and was instantly frozen. For the second one, what we're going to be doing is essentially making a little ice tower. All right, so what we're going to do is that we are going to get our glass and our ice cubes, and we are going to put the ice cubes inside of the glass just to catch it, and then slowly pour the super cold water directly from the freezer, not leaving out for a minute or so on the table, on top of it. And what we're going to be seeing is that it will actually freeze instantly and stack on top of one another. Now, before I do this, I just want to explain what's going on. So as the super cold water, meaning the water bottle from the freezer, hits the ice that we have in our glass, it's the ice nuclei that's within our glass. The crystallization, meaning the ice formation, spreads up to the stream of the water that's being poured. And so the latent heat that's released from the freezing process strips it from the freezing solid state. Now, dropping an ice cube directly down into a glass of water that contains super cold water, or just touching an ice cube to the surface of super cold water provides the nuclei needed for the super cold water to freeze completely. Now, when ice freezes, the water forms small, tiny little crystals that gradually spread. As we know, that ice is water within a lattice structure. Now, if you catch the cold water before the crystals have time to form, you can still pour out the water, and it will actually freeze as you pour. Now, pouring it over an ice cube or a cluster of ice cubes in a glass triggers the crystals to form faster than they normally would. As we see when we will pour it just in one moment over the ice cubes in our glass, we're going to see a little ice structure form. You ready? Let's do it. All right, so let's do this. as we can see, slowly but surely, a little bit was forming on the top of it. Now, it's probably a little bit, it's already starting to melt with my warmth of my hand. It's also pretty warm in here. You can still try to do a little bit, and it's already too warm. So as we saw when we were pouring it, a little bit of ice was forming up on the top of our ice cubes as you're pouring our super cooled water. Unfortunately, you have to do this pretty instantly because this change in temperature can actually, just a couple of seconds, or the heat of your hand or the heat of your apartment, in my case it's now up to 76, can definitely affect the super cooled water and the experiment to go wrong. But we saw it happening earlier, and it's already starting to melt because, yet again, everything is super warm in here, and as you can see, even from the steam from my hand, already starting to affect the glass, so it's pretty warm. So just make sure that when you do this, it might be better for you to do it right next to your freezer to save you a couple of seconds, because those seconds could be crucial. As we know that water is great at absorbing heat. We learned about the water's properties, I think, in the first or second video that we did. So that being said, your best bet is to do this right next to your freezer. Well, these are even starting to fog up my glasses. So that being said, it's best that you maybe do this right next to your freezer, or make sure that your apartment isn't super hot, but I don't really have control of that, unfortunately, landlords. So yeah, but as we saw when we were pouring our super cold water from the bottle, it was starting to form a little bit of ice sculpture up on top. All right, well, thanks for today's experiment. If you have any questions or comments, please comment below. All right, thanks so much, and I appreciate you all watching, and have a good holiday.